Hello and welcome to this second video where we're going to look at the 2012 Cambridge Chemistry Challenge for the lower 6th. Today we're going to have a look at questions 1C and 1D. Just like to remind you, I'm in no way associated with the challenge, and this video is designed as a walkthrough for students who attempted this paper as part of their preparations. With that in mind, let's begin. Okay, so question 1C is prefaced by this information here, where they tell us about the dilution scale used in homeopathy. It uses this system where you have D followed by a number, and this number is the factor of 10 that it has been diluted by. So for example, D1 has been diluted by 10 times, D2 by 100 times, so on and so forth. It then tells us that arsenic amalgam is often sold as a D30 preparation before giving us the mass of arsenic oxide, which would be dissolved in a saturated solution. So the question then asks us to calculate the mass in grams present in a 100 centimetre cubed glass of the D30 remedy. So using the information that we have here in the volume they've given for us, let's have a go at this. So here we can see they've asked us for the mass of AS2O3 in 100 centimetres cubed, and we should remember that in the saturated stock solution there's 20.6 grams per decimetre cubed, and we're working with a solution factor of D30. So if there's in 1 decimetre of the stock solution, 1 decimetre cubed, we're expecting it to be 20.6 grams. Therefore, in 100 centimetres cubed, which is 1/10 of a decimetre cubed, we would expect it to be 2.06 grams. Now we're going to then further dilute that by a factor of 10 30 times. So in this 100 centimetres cubed, we could expect it to be 2.06 times 10 to the minus 30 grams, which is hopefully the answer that you have got. For the next part of this question, they're asking us to calculate what volume of the solution we would need for a fatal dose of arsenic amalgam, given that 0.1 grams is normally fatal. They'd also like us to express this as a fraction of the volume of the earth. So let's give this one a go. Okay, so this is going to be a question where there's a lot to do, so it's going to be important to lay our work out logically here. So you can see I've just noted down some important information at the top: the volume of the earth in kilometres cubed, and also the fatal dose. Now, using what we worked out in the previous question, we know that 100 centimetres cubed of this solution contains 2.06 times 10 to the minus 30 grams. So, in 1 decimetre cubed of this solution, we would expect it to be 10 times as much, so 2.06 times 10 to the minus 29 grams. How many decimetres cubed do we need for 0.1 grams? To do that, we're going to do 0.1 divided by 2.06 times 10 to the minus 29. Nearly caught myself out there. And that gives us an answer of 4.854 times 10 to the 27 decimetres cubed. Now, in the question, they asked us to express this as metres cubed, and we should hopefully know that a metre cubed is 1,000 times larger than a decimetre cubed. So if we do 4.854 times 10 to the 27 over 1,000, we should hopefully see that this is 4.854 times 10 to the 24 metres cubed. So that's the first part of the question done. Now they want us to express this as a fraction of the Earth's volume. Now they've given us the volume of the Earth there in kilometres cubed, but we are going to need to convert that to metres cubed. Now a kilometre cubed to a metre cubed is a scale factor there of 10 to the 9, or 1 billion. So there are 1 billion metres cubed in a kilometre cubed. So what we can do is we can take the volume of the Earth, which is 1.08 times 10 to the 12, and we can times that by 10 to the 9, and then the volume of the Earth in meters cubed is 1.08 times 10 to the 21 meters cubed. Now, we're going to need to divide our answer for the meters cubed of the solution we need by the volume of the Earth. We do 4.854 times 10 to the 27 divided by 1.08 times 10 to the 21, and that gives us a total of 4,500 times the volume of the Earth. So if you're going to consume that much of a solution, you're going to have bigger problems to worry about before you actually manage to consume the fatal dose of the arsenic oxide. Let's see what they'd like to do in part 3. So in part 3, we're asked to work out how many bottles of the solution would need to be bought in order, on average, to include 1 atom of arsenic. So we're going to be using some moles here and some volume calculations as well. Okay then, so let's start off by finding out how many moles would be present in 1 decimeter cubed. So moles in a decimeter cubed is going to be 2.06 times 10 to the minus 29. Remember, we calculated that as the mass present earlier, divided by the relative formula mass, which is 197.84, and that tells us that in 1 decimeter cubed we have this many moles, which is a very small fraction of a mole. 24541 times 10 to the minus 31 moles. So that's a very long number. I like to leave the numbers with as many significant figures as possible until we get to the final answer to make sure that the answer is accurate. So we don't know, but the ratio of As2O3 to arsenic is 1 to 2. So therefore, the moles of arsenic will actually be twice that number. So they're going to be 2.08249092 times 10 to the minus 31 moles. Now, this will allow us to calculate the number of atoms in a decimeter cubed. So, atoms of arsenic in 1 decimeter cubed are going to be our answer from there. So 2.08, etc., 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 times 10 to the minus 31 multiplied by Avogadro's number, which gives us a grand total of 1.253659523 times 10 to the minus 7 atoms of arsenic per decimeter cubed. So therefore, to work out decimeters cubed needed for 1 atom, what we'll then do is we will divide 1 by that answer. And that's going to tell us that we need 7.977 026 times 10 to the 6 decimeters cubed. And therefore, that would be equal to 7.977 times 10 to the 9 centimeters cubed. And if we then divide that number by 28, that will tell us that what we'd actually need to do is purchase 2.85 times 10 to the 8 bottles. Or, to convert that into layman's terms, 285 million bottles. That's a rather large number of bottles of what's effectively pure water to buy. And that's how we would work out the number of bottles for 1 atom of arsenic. So, in question D then, we're going to have a look at working out these dilutions of hydrochloric acid. We're told that we'll start with this 1 mole per decimeter cubed stock solution. So remember, every D number is a dilution of 10 up to that amount. So D2 would be times 10 to the minus 2 moles per decimeter cubed. We start off with 1, so it's 1.0. I'm going to miss the units out at this point, but make sure you wrote them in your own answers. D4 would be 1.0 times 10 to the minus 4. D6 would be 1.0 times 10 to the minus 6. D8 would be 1.0 times 10 to the minus 8. And D10 would be 1.0 times 10 to the minus 10. So that's how we'd work this out. Like I said, remember to write your units in. So these are moles per decimeter cubed. Thank you for watching this video then, where we've gone through questions 1C and 1D. I hope you found it useful. If you'd like any further clarification, please let me know in the comments. And I'll see you for our next video, where we'll look at parts E and F of question 1. Thank you very much.